Hello and welcome. Have you come across questions like this before? If you have, you will know that it's very frustrating because when you read the solutions, it's really simple. It's just 3 or 4 lines, but it's very hard to make sense of. You could spend 30-40 minutes reading the same 3 or 4 sentences, but nothing gets in. The next thing that most students will do is, you know what, I'm just going to memorize this because it's really simple. Now that is a mistake. So in this video, I'll go into detail. I'll explain what's going on so you never have to memorize this type of questions again. But first, I will have to introduce the problem in case you have not come across this before. For this type of questions, we're going to first have maybe a scalar product form of a plane. Question will be asking what is the distance of this plane from the origin. And now I will summarize what you'll see in the solutions. First of all, you're going to need to modulus, right? This value over here, in this case is -5. I'm going to turn it into +5. Secondly, right, I need to find the magnitude of my normal vector, which is √6. Now, if you combine the two of them together, you have 5/√6. That's it. That is how simple it is. But why? Now, before I go into the why, there are actually 2 fundamental concepts of vectors that you need to understand very well in order to fully benefit from this video. So, first of all, you need to know length of projection really well. Number 2, you also should have come across this problem in your head. Okay, why is the scalar product form so crazy? Right? By crazy, I mean that, think about it, right? R dot n equals to a fixed constant. Why is that so? Let's first start with length of projection. So I find the most helpful way to think about length of projection is if you have an object and then you want to cast a shadow. Think of the projection as the shadow of the object. Okay, and then maybe you can imagine maybe you have a light source coming from far away. Okay, and then you cast a shadow onto a new surface. Okay, and that is the projection. In the vector world, what that looks like is you have this formula over here. A is your object. You dot it with the unit vector of the new surface that you want to cast a shadow on. Okay, think of dot as like casting a shadow onto, right? So A casts a shadow onto this new direction called n. Okay, remember that a unit vector really is nothing but just a notion of direction. Okay, great. Now let's move on to the second thing. Why is r dot n so crazy? Yes, think about it. If I have a plane that looks like this, right, and I just pick 3 random points on the plane, A, B, and C, what r dot n equals to a fixed constant is telling me is that if I take OA, which has some x, y, z, maybe like coordinates 1, 2, 3, I dot it with the normal vector, that will be equals to OB, which has maybe coordinates -2, 5, 8, right? And you dot it with the same n, these 2 values are the same. Not only that, if you dot it with, say, another point on the plane, maybe 10, -15, 6, that as well is the same as everything that you've done before. Isn't that a bit crazy? Why should they be the same? Okay, so let me explain why that is so to you now. Now, if I were to redraw the plane this way, right? So the plane's over here, the one in black. Okay, and then point A is over here. Now, if you look at the length of projection, right? Length of projection. Again, what are we doing? We are taking A and we are casting it onto the new surface N. So that means we are shining light this way, right? Okay, and then the shadow of A will be cast on over here. Okay, that will give me sort of like the length of projection. There will be A dot n cap, which is mod A, mod n cap, and then cosine the angle between the 2 vectors. This is basically the definition of the dot product. A dot B is mod A, mod B, cosine angle between the 2 vectors. Okay, and because n cap is a unit vector, this is equals to 1. So I end up having mod A cosine alpha. And mod A cosine alpha, mod A, you can think of it as the hypotenuse because this is right angle. Okay, hypotenuse times cosine will give you the adjacent side, which is this one, the length of the side. And that actually is the distance to the origin. So if this doesn't make sense, pause the video over here and try to see, right? Try to go through it and see if it makes sense. This should also work if you look at, say, a point like B, right? If you look at B, B is different from A, but it's also on the plane. But since it's on the plane, then we can do maybe the length of projection, right, of this one. Okay, so what you're going to have is mod B, mod n cap cosine beta, where beta is the angle between B, and the normal, and it pretty much works out to be the same. Okay, in fact, this will also work if I have a point C on the plane, right? So again, it's really important that you understand what's going on over here. Pause the video, right? Try and work it out. Okay, a tip is that you might need to use your Sec2 trigonometry, right? Using right triangles. The distance to the origin, right, from the plane to the origin really is just this, A dot n cap, right? Compared to what we had earlier in the question, right? We had A dot n. Yes. How can we change A dot n into A dot n cap? Okay. What you can do is, right, first of all, A dot n cap is A dot n, but you need to modulus first. Remember, you need to modulus this thing. Yeah, because the length of projection is a mod. Yes, so what you're missing is a mod, so you need to mod this first. Okay. Then remember that this is n cap and this is n. You need to divide by the magnitude of n. Okay, those are the exact two steps, right? That is in your solutions. What is the takeaway? The takeaway is not to memorize this, right? Whenever you're asked about the distance of a plane from the origin, you should always look at it as a length of projection. And maybe think of it as shining a torchlight this way, so that you get the length of the shadow over here. And this shadow is the distance from the origin. This is the takeaway that you should have. If you can understand this, then you'll be able to make sense of this question and why the solution is the way that it is. Okay, so I hope you found this helpful, and then yeah, I guess I'll see you in the next video.